My name is Veeraswamy, working as Assistant Professor in the Department of Electronics and Communication Engineering in Institute of Aeronautical Engineering, Dundigal, Hyderabad. We are going to learn the course is a mobile communication system. In that course, today's topic is the limitations of conventional mobile telephone system. So, we are entering into this before the basic concept the students have to know, that is the basic concept of wireless communication system, that is wireless communication network and cellular mobile communication system. So here in this course, today's topic is the limitations of conventional mobile telephone system. So these are the contents, that is the introduction to cellular mobile radio system, that is introduction topic. Today we are going to learn these are the topics, that is introduction, limitations of conventional mobile telephone systems and basic cellular mobile system. So in this here, what is mobile communication? So here the communication is nothing but the process of exchanging of the information from one place to the another place or source to the destination, that is called as the communication. So here the different types of communications are available in the today's generation, that is analog communication and digital communication. So here the mobile communication is nothing but here the analog communication is nothing but transferring the information from analog source to the analog destination. The same as the digital communication is nothing but transferring the digital information from the source to the destination. So here the mobile communication is nothing but it is the process of communication while moving around a wide geographic area. I am repeating, it is the process of communication while moving around a wide geographic area, that is called as the mobile communication. So to do the mobile communication, we have to establish the mobile communication by using different modules. So here the portable handheld devices used at a walking speed. So here the mobile communication is the process of communication while moving around a wide geographic area. The portable handheld devices used at the walking speed and stay connected in everywhere wherever we want to go. That is the mobile communication is connected to the always it is connected, stay connected in everywhere we go. The next one is the stay connected in many ways. So here after establishing a connection from the source to the destination, that is always connected, the stay connected in many ways, that is by using calls or video or audio, that is etc. These are the different types of connected ways. The next one is the communication facility between stationary and mobile or mobile to mobile units. So here I am repeating the communication facility. So here the mobile communication facility between stationary and mobile. So here see, the stationary is nothing but a constant or unmovable, that is a stationary, and the mobile is here is the movable. So here the user can travel from one place to the another place, he can that is the movable. So the communication facility between stationary and mobile are mobile and mobile users, that is the mobile communication. So the concept of the mobile communication is a conventional mobile telephone system is usually designed by selecting autonomous geographic zones. So for example here I am repeating, the conventional mobile telephone system is usually designed by selecting autonomous geographic zones. So here that is up to 50 miles. So here the geographical zone, so the complete environment, so here the geographical area is divided into zones. So each zone is up to 50 miles of the coverage area. So the concept of the mobile communication here is the conventional mobile telephone system is usually designed by selecting autonomous geographical area or autonomous geographic zones. So one or more channels from a specific frequency allocation for a use in the geographic zones. So here one or more channels from a specific frequency allocation. So here the frequency is taken from the electromagnetic spectrum. So here the different types of frequencies or the different types of waves are available in the electromagnetic spectrum only, like the radio waves, light waves, infrared, X-ray. So these are the different types of waves are available in the electromagnetic spectrum. So in this electromagnetic spectrum, the specified frequency bands, that is nothing but here, for example, to increase the speed of the transmission, so we are taking high speed of the frequency band. So here the bandwidth is high. So one or more channels from a specific frequency allocation for use in the geographic zones, and the high powered transmitters are used for the coverage. So here to cover the geographic zones, that is to cover the autonomous geographic zones, we are using high powered transmitters for the coverage of the autonomous geographic zones. So these are the concept of the mobile communication. So for example, this is the example image to explain the mobile communication operation. So see here. So here is one antenna and here is another antenna, here is another antenna. So these antennas are also called as the base stations in the mobile communication system. So here one house is there and here is one mobile, here is mobile, and here is the movable particle, that is the mobile vehicle is there. So for example, here three zones are allocated. For here, this is one zone, the autonomous geographical zone. Three different types of geographic autonomous zones we are designed to for the better communication or to transfer the information by using different mobile communication. So here see, this is one base station and here is the another base station, and here, so total three base stations are there. So what is happening here, to cover this complete geographical zone by autonomous, the selected towers or selected base stations with here the constant, here the house, the person is in house, he is a constant person, that nothing but here it is a constant place, and here the vehicle is there, this vehicle is a mobile vehicle. So for these, the small antennas are also available in the geographic zones. See here, I am rounded that, and these are the base stations to cover the high power transmitters are used to cover the geographical zone areas. So this is the best example for the mobile communication operations. The next here, the examples of the communication system. So how we are transferring the information from the one place to the other place by using mobile communication system. So see here, right. So here the different types of techniques are used to transfer the information. That is, one is the simplex mode, that is the pager. So here this is a pager. The pager, the simplex is not, we will discuss one by one what is simplex. The next one is handheld walkie-talkies. So these are the handheld walkie-talkies, and that mode is half duplex transmission mode. The next, these two are cordless phone and cellular phone. These two are the full duplex transmission mode. So here to transfer the information from one place to another place, basically three types of transmission modes are available. That is, the first one is simplex mode, the second one is half duplex, and the third one is full duplex. So what is a simplex? So see, a pager here, we only receive the information from the transmitter. So the pager acts as always a receiver only. But say here the walkie-talkie is there. The walkie-talkie is nothing but here, sometimes it acts as a transmitter and sometimes it acts as a receiver. The same time, the cordless phone and cellular telephone systems are also the transmission of the information. The cordless phone acts as a transmitter as well as a receiver at a time. So we will discuss one by one what is simplex. Then see the classifications of wireless systems. So basically the transmission modes, the classifications of wireless systems is also defined as the transmission mode or the data transmission mode. So here three types of data transmission modes are available. That is, the first one is simplex. So I will explain the simplex mode. So here the simplex is nothing but, so here one transmitter is there and another the receiver is there. A connection is established by using different types of transmission medias, right? So we will discuss different types of transmission mode, then after we will enter into the simplex. So here the basic requirement or the basic components, the basic components are required to establish a communication by using mobile communication system. The basic components are, the first one is transmitter, the second one is a receiver, the third one is, to connect the transmitter receiver we required channel, and the fourth one is protocol, and the fifth one is information. So these are the different types of or basic components required to establish a communication or to transfer the information or to exchange the information from one place to the another place. That is the communication. Mobile communication is nothing but here to establish a connection between transmitter to receiver and the transfer the information or transmission of the information. So here the basically the transmitter and receiver. So in mobile communication system, the transmitter and receiver always acts as vice versa. That is, the transmitter sometimes acts as a transmitter and sometimes it acts as a receiver. The same time, the receiver is also sometimes acts as a transmitter, sometimes acts as a receiver. So here it is the combination of the transmitter and receiver is also called as the transceiver. So here in mobile communication system, the transceiver or the transmitter and receiver always the antenna is acts as a transmitter as a receiver. Next one is the channel. So what is channel here? So basically channel is nothing but to carry the information from the source to the destination, that is called as the channel, or the channel is also called as a transmission media. Transmission media. So basically here what is happening, the transmitter and receiver both are nothing but here antennas only, right? Transmitter is also antenna and the receiver is also an antenna. So the transmitter and receiver are connected by these two are connected by a channel only. That channel is also called as a transmission media. So here in communication system, different types of transmission medias are available for the exchanging of the information. So basically the types of transmission medias. So the types of the transmission medias are categorized into two types. The first one is guided transmission media, and the second one is unguided transmission media. Then see here, basically the channel or the transmission media is categorized into two types, the guided transmission media and unguided transmission media. So here the guided transmission media is also categorized into three classifications here. The first one is twisted pair cable, and the second one is coaxial cable, and the third one is optical fiber cable. But here is only air. I will explain one by one. So here the guided transmission media is also called as a wired transmission media. Here a guided transmission media is also called as a wired transmission media, because of here we are transmitting the information by using wires. So that type of media is called as a wired transmission media or guided transmission. So here guided, see the name. The guided is nothing but we are providing a guide, or we are providing a path to transfer the information from transmitter to the receiver. For example, it is a transmitter and it is a receiver. So we are connecting by using a cable. So here by using cable we are transferring the information, or we are providing a path to carry the information from the source to the destination or transmitter to the receiver. So that type of transmission media is called as a guided transmission media or unguided transmission media. So here basically the guided transmission medias are categorized into again three classifications are available. That is, the first one is twisted pair cable, the second one is coaxial cable, and the third one is optical fiber cable. So here these are the different types of cables or different types of wire. So I am repeating here, the type of transmission media, guided transmission media is also called as a cable transmission media or wired transmission media, because of here we are using wires or cables. By using cables or wires we are transfer the information, or we are transmitting the information from the source to the destination. So that type of transmission media is called as a guided transmission media. So the cables are categorized into three types in the mobile communication system or communication system. That is, the first one is optical fiber cable, the second one is coaxial cable, and the third one is twisted pair cable. So here basically three cables: twisted pair cable, coaxial cable, and optical fiber cable. So we will see what is one by one. So here twisted pair cable is nothing but two cables or the pairs of cable, twisted pair cable. So listen, I am repeating once again, twisted pair cable. The twisted means two cables are twisted together. I am repeating, twisted pair cable. So pair is nothing but two cables, right? So two cables are twisted together. That type of cable is called as a twisted pair cable. So the structure of this twisted pair cable is nothing but here a helical structure. So already you know the helical means the structure, the DNA structure. So how it is the DNA structure? For example, it is cable 1 and it is the cable 2. Cable 1 and cable. So this is the structure of the DNA, right? So but here it is like this. So here two cables are twisted together. So this type of cable is called as a twisted pair cable. Like the structure of the twisted pair cable is helical structure, and this is the structure here. Here the copper wires are used to carry the information. The copper wires are used to the copper material. So here in the twisted pair cable, the material used to carry the information from the source to destination is, that is, copper material used to carry the information, that is twisted pair cable. The next one is coaxial cable. Coaxial. I am repeating, coaxial cable here. The coaxial cable is nothing but again two cables are attached together. That is nothing but again a pair of cable is attached together to carry the information from the source to destination. So that type of cable is called as a coaxial cable. So here again same, the copper material is used to carry the information from the source to the destination. The next one is optical fiber cable. So what is optical fiber cable? Already you people know the optical fiber cable is nothing but to carry the information, the long distance communication purpose we are using the optical fiber cable, right? So here the optical fiber cable is made up of the glass material. The glass material is used to prepare the manufacturing of the optical fiber cable by using glass material. So here the optical fiber cable is works on the Snell's law. Snell's law, by using on the principle of Snell's law only, the optical fiber cable is works. So what is Snell's law here? N1 sin theta 1 is equal N2 sin theta 2. So here what is N1, what is N2, and what is theta 1, what is theta 2. So here the structure of the optical fiber cable is this one. Here core and cladding, and this is the transmitter side and this is the receiver side, are two ends, right? So here when the information is connected to this optical fiber cable, it carries the information like this. So what is happening here? This is the transmitter side, we are connecting the information to the optical fiber cable. That optical fiber cable is connected to the receiver side, the information is received at the receiver side. So the traveling or the path of the information is in this type. So here I am giving the directions also here, right? So when it enters into the optical fiber cable, it takes reflections and again, and it travels to the receiver side. So what is here? The reflections again and again taking, that is called as the total internal reflections. So the principle of the optical fiber cable is the total internal reflection takes place in the inside of the optical fiber cable and it travels to the receiver side. So here N1 is nothing but the angle of incident of the core side, and theta 1, that is N1 is nothing but the core material N1, and theta 1 is nothing but incident angle, and theta 2 is reflection angle. So this is incident, that is theta 1, and this is theta 2. And again here it is incident theta 1 and it is reflection theta 2. And here N1 is nothing but core material, N2 is nothing but here cladding material mode. So again it travels to the receiver side. This is the optical fiber cable. And see, listen. So here in optical fiber cable, the light is used as the light is used to carry the information from the source to the destination. But see here in the twisted pair cable as well as in the copper cable, that is coaxial cable, copper material is used to carry the information, right? But in optical fiber cable, light as a source or light as a carrier in the optical fiber cable to carry the information from the source to the destination. So this is the different types of guided transmission media. So by using cables, right? I am repeating once again, the optical fiber cable, twisted pair cable and the coaxial cable. These are the three types of cables to carry the information from the source to the destination. So these are the guided, right? We are providing a path, or we are allocating a guide to transfer the information or to carry the information from the source to the destination. Now again, and here unguided transmission media is also there. Unguided transmission media. So what is unguided transmission media? So in guided transmission media, different types of cables are used to carry the information. But here in unguided transmission media, the air is acts as a medium, or air is acts as the to carry the information. Air is carrying the information from the source to the destination. So how air is carrying the information? Because of here, the unguided transmission media is also called as a wireless transmission media. So here the unguided transmission media is also called as the wireless transmission media. So without using any cables, without using any wires, we are transmitting the information from source to the destination. But how it is possible? Because of here, the electromagnetic spectrum, we are using to carry the information. So the electromagnetic spectrum is nothing but the electromagnetic waves are available in the air, right? So that's why here air is carrying the information from source to the destination. That type of transmission media is also called as the unguided transmission media. And here the antennas and towers are used to carry the exchanging of the information. That is the different types of cables, right? See, so now we are entering into the classifications of wireless system, that is simplex and half duplex and full duplex. So what is a simplex? The simplex is nothing but it is only of one way of communication. See here, it is transmitter and it is receiver, and the connection is established to between by using a transmission media. This is transmitter and this is receiver, and we are establishing a connection by using the channel or transmission media, right? So here the simplex is nothing but the transmitter is always acts as a transmitter only, and the receiver is always receives the information. So only one way of transmission is called as the simplex. So the best example is just now we saw the image, that is a pager. So he always the pager is only receives the information, cannot gives the acknowledgement to the transmitter. The next one is half duplex. So here half duplex is nothing but, again here I am giving example here. See, this is the transmitter side and this is the receiver side. So what is happening here? The half duplex is nothing but the connection is established to transmitter to the receiver. So sometimes acts the transmitter transmit the information and it receives the information from the receiver. So here the bidirectional communication, So here a two-way communication, bidirectional or two-way communication. So what is happening? The transmitter transmit the information. After transmission it completes, the receiver receive the information and again gives the acknowledgement. So here the half duplex communication is the half duplex wireless system classification is nothing but here the bidirectional communication done but not at a time. Bidirectional communication but not at a time. So that type of communication is called as the half duplex communication. Then what is full duplex? The same again. So the example for the half duplex is walkie-talkies. So the walkie-talkies are the best example of the half duplex communication. Then what is full duplex? Then see. So again here transmitter and here receiver. The transmitter and receiver. So the connection is established. So it is also the bidirectional communication but at a time. So here the transmitter acts as a transmitter as well as a receiver. Same time the receiver is also acts as a transmitter, acts as a receiver. But so see here the information, exchanging of the information done at a time between the transmitter and receiver, that type of communication is called as a full duplex communication. So these are the different classifications of wireless communication. I am repeating: the simplex, half duplex and full duplex. The simplex is nothing but the transmitter always acts as a transmitter and the receiver always acts as a receiver. So that type of communication is called as the simplex communication. The next one is half duplex communication. Half duplex communication nothing but the bidirectional communication done between the source to the destination but not at a time. Sometimes the transmitter acts as the transmitter and the receiver acts as the receiver. That is the bidirectional communication not at a time. That is half duplex communication. The next one is full duplex communication. The full duplex communication nothing but the bidirectional communication or the exchanging of the information from this transmitter to the receiver at the same time. So that type of communication is called as a full duplex communication. So see here what we have discussed just now, different types of the classifications of different types of transmission medias, that is guided and unguided transmission medias. So where we can use the guided and unguided transmission media at the time of exchanging of the information or to establish a connection between transmitter and receiver, we are using the guided and unguided transmission media. Let's see, just now we discussed the simplex. The communication is possible in only one direction. That is nothing but here only one way of communication is nothing but simplex. That is paging system is nothing but here a simplex, example of the simplex transmission. The next one is half duplex communication. That is nothing but here two-way communication but not simultaneous. That is nothing but it is two-direction communication, bidirectional communication but not at a time. That the best example is walkie-talkies for the half duplex transmission. The next one is full duplex communication. So here the full duplex communication is nothing but two-way communication, simultaneous communication. That is two-way simultaneous communication. That is the cellular system is nothing but here full duplex communication. So these are the different classifications of wireless system. The next, so just now we discussed that duplex, right? Actually, what is duplexing? What is duplexing? In wireless communication system, it is often desirable to allow the user to send simultaneously information to the base station while receiving the information from the base station. For example, the base stations are here are nothing but the transmitter base station and the receiver here. It is the transmitter and it is the receiver. So what is duplexing here? The duplexing is nothing but it is often desirable to allow the user to send simultaneously information to the base station. So here it is base station. The transmitter gives the information to the base station and from the base station to the receiver, the exchanging of the information. Again the receiver gives the acknowledgement and it gives the base station gives the information to the user. So that is the duplexing. So here again the duplexing is categorized into two types. So according to the duplexing is done either the frequency or time domain technique. So basically the duplexing are categorized into two types according to the user specification. That is frequency division duplexing and the second one is time division duplexing. So what is frequency division duplexing? The frequency division duplexing is more suitable in radio communication system and the time division duplexing is again here is used suitable for the fixed wireless system. So I am repeating here the duplexing is nothing but it is to allow the user to send simultaneously information or simultaneously exchanging of the information to the base station while receive the information from the base station. That is duplexing. So the duplexing is done in two ways. That is two techniques are available. That is frequency division duplexing and time division duplexing. So here the frequency division duplexing is suitable for the radio communication system and the time division, that is the TDD, the time division duplexing is suitable for the fixed wireless system. So what is frequency division duplexing? So here the frequency division duplexing nothing but here two bands of frequencies for every user. In the mobile communication system, two types of duplexing systems are available, right? So here frequency division duplexing nothing but here for every user two bands of frequencies are allocation. The allocation done two frequency band. That is one is forward band and the second one is the reverse band. So here the forward band and the reverse band. The forward band is nothing but uplink and the reverse band is also called as the downlink. I am repeating here the frequency separation between forward band and the reverse band it is constant. I am repeating your frequency division duplexing nothing but for every user we are allocating of the two frequency bands. One is forward frequency band and the second one is reverse frequency band. And these two, the frequency separation between reverse band and forward band is constant. So here FDD provides, see here, one is forward band and one is reverse band. So for example, here it is user 1 and user 2. User 1 is a transmitter and there is a receiver, and here it is also a receiver as transmitter and it is receiver. So two frequency bands, we are engaged of the two frequency band, right? So one frequency is forward frequency band and one is reverse frequency band. So the frequency band, the forward frequency bands to carry the information from the source to the destination. After reaching at the destination, the information, then the reverse frequency band will activate. That will be activates to carry the acknowledgement from the destination to the source side. Then see, FDD provides two simplex channels at the same time. Two simplex channels. So here forward frequency band and reverse frequency band, two simplex channels. One channel is forward frequency band and the second one is reverse frequency band. So here two simplex. So just we discussed the simplex is nothing but only the transmitter, that is called as the simplex. So here the channel 1 and channel 2. So here for every user, for example, I am taking channel 1 is a one user and we are giving reverse channel and forward channel frequencies here. Then see, the forward channel frequency is always high, that is 870 megahertz of frequency where allocation for the forward. And for the reverse band channel or reverse channel, we are allocating 820 megahertz of the frequency band. These are the frequency division duplexing. I am repeating, the frequency division duplexing is nothing. Duplex is nothing but allocation of the information to the base station to the user and user to the base station. So here the frequency division duplex is nothing but two frequency bands are allocation for the every user, what is forward frequency band and the reverse frequency band. So the separation between the forward and reverse band is constant band, that is the constant frequency band is available. The next one is the full duplex, that is the frequency division duplexing allocation for the two simplex for the two simplex channel at the same time. The next one is time division duplexing. So here the time division duplexing nothing but the user time for forward and reverse, same as what is frequency division duplexing, that is forward band and reverse band allocation. But here the user's time for the forward and reverse. So the complete that it is divided into time slots. The time division duplex is nothing but to transfer the information or the exchange of the information according to the given time slots only. That is the time division duplexing. Again here two types of time slots are available. Two types of time slot, that is forward time slot and reverse time slot. So the multiple users share a single radio channel. So here the single radio channel shares a single radio channel. I am repeating here, multiple users shares a single radio channel. What does it mean here is from the transmitter to the receiver side or source to the destination, the multiple users are connected to a single shared channel. So here the multiple users in between source to the destination. So this type of connection is called as the bus topology. I am repeating here, in between transmitter to receiver, multiple users are connected to a single shared channel. That type of connection or that type of topology is called as a bus topology. So what is happening in the time division duplexing? Multiple users shares a single radio channel. For it is the single shared channel in nothing but here it is a single radio channel. Here the time slots are allocation for the each user to exchanging of the information, that is forward time slot and reverse time slot. The TDD provides, the time division duplexing provides two simplex time slots on same frequency band. So that type of duplexing is called as time division duplexing. The next one here is the limitations of conventional mobile telephone system. So here different limitations are available for the drawbacks. The limitations of conventional mobile telephone systems are one of the many reasons for developing a cellular mobile system, that is cellular mobile telephone system, and deploying it in many cities in the operation limitations of conventional mobile telephone system. So basically here three limitations are available for the conventional mobile telephone system, that is limited service capability, poor service performance, and inefficient frequency spectrum utilization. So we will discuss one by one what is the limited service capability drawback, then what is poor service performance and inefficient frequency spectrum utilization. So here the limited service capability. So each area is allocated one or with one or more channels. I am repeating, each area. So here in cellular mobile communication system or conventional mobile communication system, the autonomous geographical area is established for the covering of the exchanging of the information, right? So in each area allocated with one or more channels, which is a large autonomous geographical zone, right? So the transmitted power should be at high as the federal specifications allows. The transmitted power should be as high as the federal specification allows. The user who starts a call in one zone has to reinitiate the call when moving into new zone because of the call will be dropped. So I will explain here what is the limited service capability here by taking one example. So for example, this is zone A and this is zone B. This is zone A and zone B. No, I will try here. So this is zone A and here zone B. Zone A and zone B. So here the base station is established. That is one antenna is established here and here also one antenna, right? So the coverage area, so it is in the radius, right? The coverage area is up to, for example, I am taking 50 miles, and this is the coverage area of this mobile station, that is MTS is also 50 miles. But the ending of zone A and the ending of zone these two, right? So the distance between these two are 110 miles. So here 50 plus 10 plus 50. So here the 50 is nothing but zone A and this is for 15 minutes zone B. So the distance between zone A to zone B is 10 miles. So what is happening here? A person is moving. He established a call in zone A and moving towards to the geographical area ending zone, and he leaves this place and the coverage area he is leaving. So automatically what is happening? The coverage area of this base station is up to 50 miles only, right? So the person when enter into the after 50 miles, automatically the call is connected, right? So there is no frequency, right? Because of the call, automatically the network is disconnected to the mobile unit to the or the conventional unit to the base station. So what is happens here? The automatically call is disconnects, right? So again, when he is entering into zone B, he have to again reinitiate. You have to reinitiate the call again. So this is the main drawback of the conventional mobile communication system, the conventional telephone communication system. So here what is happening? When he is leaving one zone and entering into the another zone, the call is automatically disconnecting. That is, the call will be dropped. This is the main drawback. So limited service capability only. So within that zone only, the call is connected. After he is leaving the zone, we have to again reinitiate the call. So this is the main drawback of the conventional mobile telephone system, that is limited service capability. Let's see, this is the best example. So we will discuss here. So this is the base station in the zone 1 and this is the base station in zone 2. And here a person connected to this zone A base station and he is moving towards zone B. Automatically, just now we discussed that. So when he is leaving zone 1 and entering into the zone 2, automatically the call is disconnected, right? So how to overcome this limited service capability? Then we have to place the high power transmitter to cover the whole area. Then see here, when I given the example also here, this is nothing but here it is call reinitiate. So the cell site is here. When we are leaving zone 1 and entering the zone 2, we have to again reinitiate the call. So this is the limited service capability, the limitation of conventional mobile telephone system. The next one is here the continuation. So to overcome this, to overcome the limited service capability, that is, we are introduced that the handoff mechanism. So what is handoff mechanism here? The handoff mechanism, it is a process of automatically changing frequencies as the mobile unit moves into different frequency zone, so that the conversation can be continued in the new frequency zone without redialing. So nothing but here, no need to reinitiate the call to the base station. So here the handoff mechanism is nothing but no need to re-establish the connection to the base station to the transmitter. So here without establishing any connection, so automatically changing the frequency as the mobile unit moves into a different frequency zone, so that the conversation can be continued with a new frequency without any dialing. So that is the handoff mechanism. So the another disadvantage of the conventional system is that the number of active users is limited to the number of channel assigned to a particular frequency zone. The next one is the poor service performance. The poor service performance here, in the past, the total of 33 channels were allocated to 3 mobile telephone systems. So in the past, the total of 33 channels were all allocated to 3 mobile telephone systems only. So the mobile telephone service, the MTS is nothing but here mobile telephone service, that is 40 megahertz of frequency utilization. Then when MTS to the improved MTS, that is IMTS, the MK system, that is 150 megahertz of frequency band, and here the improved MTS, that is MK device, that is 450 megahertz. Then see here what is happening. The MJ is using 150 megahertz of the frequency band and the MK is using 450 megahertz of frequency band. So total the 6 channels of MJ, 6 channels of MJ serving 320 customers, and with the 2400 of waiting list customers. Here 150 megahertz of frequency is using by the MJ systems, and it covers only 320 customers are connected, and in the waiting list total 2400 customers in the waiting list. At the same time, the MK system serving only 225 customers only, with the another 1300 customers on the waiting list. So these are the here the poor service performance. How we are saying the poor service performance? Only the 320 customers are connected and the 2400 customers on the waiting list. So here the connected customers are very less to compare to the waiting list customers in the both MJ systems and MK system. So the large number of subscribers are created the high blocking probability busy hours. So what is happening here? 2400 customers and 1300 customers. So here 225 and here is 320. So it is serving only less customers only, right? So the large number of subscribers. So the large number of subscribers created a high blocking probability during busy hours. So because 2400 customers and 1300 customers are the waiting list, and automatically the blocking probability is very high. So although the service performance was undesirable on demand was very great, because of here 320 customers are always it is serving, right? So high capacity system is for mobile telephone system as needed to cover the 2400 waiting list, also to decrease the waiting list. So these are the today's topics. Thank you. We will discuss the next limitations and further topics in the next sessions. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.